This conference will now be recorded.
Very good evening, students. Today we'll be discussing numerical problems and analytical questions on kinematics. So today's topic will be acceleration, average acceleration, constant acceleration, motion, free fall, etc. So let us read the questions and solve one by one. By doing this, our conceptual understanding will be strengthened. And I'll mention again, once again, that these questions are some of the other time was being asked in various competitive exam as well as board exam. So these are really good questions. Let us try to understand and solve. So as you see this question we could not attempt in proper way yesterday due to some reason. Let us try to read this question and understand and solve it today. So this question says a particle moving in a straight line covers half of the distance, with speed 12 meters per second. Okay. So it covers half of the distance with this speed. Then half of the distance is covered in two equal intervals with speed 4.5 meters per second and 7.5 meters per second respectively. The average speed of the particle during this motion. I'll just try to make you understand the situation. Suppose this is the total distance, okay, and half of it is traveled. So this is suppose d by 2. Total distance, let us say d, and rest of the thing is also d by 2. Okay. Now this d by 2 is covered by the particle with a constant velocity 12 meters per second. Let us say this is v1. Okay, v1, but we don't know what is the time it takes. So if I want to find out what is the time it takes to cover this d by 2, let me tell this time is t1, and this can be found out as we know the distance and we know the speed. So we know time will be distance by the speed. The speed is given as 12 meters. So you know this is d by 24. This much, this is the time. Okay, d by 24. So this is the time it takes to cover this distance. Now the second part, look, the second part, the other half of the distance is covered in two equal interval of time with speed. See, other half is traveled by two equal interval. Let us say that time is t. Okay, equal interval is t. So each interval is t, and within that it travels the remaining half, but with two different speeds with two equal intervals. That means, you know, I can say S1 distance is traveled, S1 distance is traveled with speed this 4.5 meters per second. I can say that, and that I can write like this. Okay, and S2 distance traveled with speed 7.5 meter per second, and as I have taken the time interval to be the same, time interval it takes is same. So these two, again these two, S1 and S2 will be again d by 2. Okay, so let me write it here. This is 4.5 t plus 7.5t, that is equal to d by 2. Now I can find out from here. See, this is 12t is equal to d by 2. So what is this t is equal to? T is equal to d by 24 again. D by 24. Okay. So how much time is taken here totally to cover d by 2 distance? That is 2 of this t I have obtained here, isn't it? So look, to find out average speed, what you need? The total distance traveled, that is d, average speed. Total distance, that is d, and the total time interval. What is the time interval here? The t1 plus 2 into t. This is all. Okay, this is all. Now d is d itself. So t1 is d by 24. Okay, and this 2 into t, that means d by 12. Okay, d by 12. So from here what we get? See, 24 in the numerator. See, d I can cancel. So just do the simplification. It will be 2 plus 1. That means this is in meter per second. That means, you know, this is 8 meter per second. So this will be the average speed. I hope, dear students, you have understood this. So what I have done, see, in the question it is given that first half, that is d by 2, distance is traveled with speed 12 meter per second, and the remaining half is traveled with two different speeds but takes the equal interval. Okay, so by that I can find out, like, with 4.5 meter per second speed, if it travels for t time, then it goes, like, it covers s1 distance, and remaining distance s2 is covered with another equal interval t. So I can write 7.5, and with speed 7.5 meter per second. So with that I can find out what is the equal interval of time, or so that is t. And so the total time taken by the particle to cover the rest of the rest half of the distance is 2 into t. And now I can find out average speed is the total distance, that is d, divided by the total time it takes, that is t1 plus 2 into t. So by doing that we get this option 1 to be the correct answer for this question. Okay, all right. So this was actually a doubt yesterday. I mean, we could not think in proper way, so today we could do it. Okay, so let us go to the next topic. So next topics, so we'll be discussing questions on acceleration, average acceleration, constant acceleration, motion, and free fall. Okay, so free fall, I think we'll take few questions today. Free fall questions, from free fall we'll take tomorrow again, like in the next class again. A particle moves along a straight line such that its displacement at any time t is given by this. Displacement is given. Then the velocity when the acceleration is 0. Velocity when the acceleration is 0. That means, you know, this is displacement plus 4. See, let me find out the time when the displacement is becoming 0. So I have to take, see, velocity. That means you have to take simply derivative of this displacement once with respect to time. So this will be 3t square minus 12t plus 3. This is speed, or velocity. Acceleration is again dv by dt. So take once again derivative with respect to time. Okay, so then we'll get the acceleration here, this. Okay, now acceleration, see, I have to find out the time when the acceleration is becoming 0. So if I make this 0, so what I get, t is equal to 2 seconds. So I have to find out the velocity at 2 seconds. So velocity expression is here. Let us find out what is the velocity at 2 seconds. Okay, so 3 into 2 square, sorry, this is minus 12 into 2 plus 3. So this is 12 minus 24 plus 3. So this is minus 12 plus 3, so minus 9. Minus 9 meter per second. So this was a very simple question. Now let us see this question. The position x of a particle varies with time t as this. The acceleration at time t of the particle will be equal to 0, where t is equal to. That means here you have to find out what is the time when the acceleration is becoming 0. So similar type of question. So I have to take dx dt. Okay, let me just write the x. So x is a t square minus b t cube. Okay, so dx dt is 2a t, sorry, 2a t minus 2b t. Now acceleration is 2 d2x by dt square, 2a minus 2b. Okay, so I think this is tq, I see. So this is 3 t square. So here it will be 6b t. Okay, so now acceleration is 0. Let us put this 0. Then I have to find out what is time. So 2a by 6b, that is a by 3b. So this is the time. Okay, so at what time the acceleration will be 0? So option 3 will be the correct answer for this question. Okay, so velocity of a body depends on time according to this. Okay, let me write this. This is the velocity 20 plus 0.1 t square. So the body has uniform acceleration, uniform retardation, non-uniform acceleration, zero acceleration. So a will be dv dt. Let us write that. That is, see, 0.2 into 2 t. That means what? This is point. I'm sorry. This is becoming 0.2 into t. That means, you know, the acceleration is not a constant acceleration. You can see that acceleration is actually increasing linearly with time. That means it is non-uniform acceleration. Sorry, not retardation, non-uniform acceleration. Acceleration is not constant. Uniform acceleration means acceleration is constant. Okay, with time. See, if I plot acceleration with time, it goes like this, 0.2, right? So slope will be with the 0.2 anyway, like this it goes. Okay, goes with like this. Okay, so that means, you know, it is gradually increasing, linearly increasing with time. So therefore it is non-uniform acceleration. The body is in non-uniform accelerated motion. Now This question is again interesting question. The question says a particle located at x is equal to 0 at time t is equal to 0 starts moving along the positive x direction with a velocity v which varies as this. Then the velocity of the particle varies with time as. So a particle located at x is equal to 0 at time t is equal to 0 starts moving along the positive x direction with a velocity v which varies as v is equal to alpha square root of x square root of x. The velocity of the particle varies with time. See, this variation is given with respect to the displacement or distance, whatever you say, or position. Now we have to find out the variation of the velocity with respect to time. So how do you do that? We know velocity is dx dt. So first of all, we have to find out the variation of position with respect to time, and then you take the derivative. Okay, so that is what I am going to do now. Set t is equal to 0, x is equal to 0. So let me do the integration here. This is alpha dt. So 0 to t and 0 to x. This is x to the power half. So if I have to do integration, see x to the power minus half, we can write this as x to the power minus half. See x to the power minus half dx. Okay, this is 0 to x, and this is alpha t this side. So this is, x to the power minus half plus 1. So this will be plus half. So plus half, you have to divide with plus half also. This is alpha t. That means what? That means this is x to the power half is equal to alpha a t. Okay, alpha a t. Sorry, alpha t. Half alpha t. So now if we square this out, what I get? X is equal to alpha square t square by 4. This is what we get. So if the displacement is varying like this with time, then what will be the velocity? Variation of velocity with respect to time. That is dx dt. So you get here 2 alpha square t divided by 4. So this will cancel. So v will be equal to alpha square t by 2. Okay, that means what? V varies as t. So velocity is actually linearly varying with time, even though the velocity is varying with displacement as this. Okay, so first option will be the correct answer for this question. Okay, now so we have a question over here. Starting from rest, acceleration of a particle is this. The velocity of the particle at 5 seconds. So acceleration is given as 2 whole into t minus 1. Then the velocity at 5 seconds. So this is v dv dt is equal to the acceleration 2 into t minus 1. So here starting from rest, that means 0 when t is equal to 0, v is equal to 0, at t is equal to t, v is equal to v. This is dv. So 2 t minus 1 dt 0 to t. So here it will be v, and the other side it is 2 t square by 2 minus t. That means t square minus 2t. V is equal to this. So we have to find out the velocity of the particle at time t is equal to 5 seconds. So what is v then? Say if we put the time t is equal to 5, then we get 25 minus 2 into 5. So this will be actually 15 meter per second. This is in meter per second. So this is 15 meter per second. So this is what is the speed of the particle. Okay, now this question says the velocity of a particle moving with constant acceleration at an instant t is equal to an instant t0 is 10 second 10 meter per second. After 5 seconds of that instant, the velocity of the particle is 20 meter per second. The velocity at velocity at 3 seconds before t0. That means the particle velocity of particle at t0 is equal to 10 meter per second. I'm sorry, this is the time. Okay, at t is equal to t0. At t is equal to t0, the velocity of the particle is given as 10 meter per second. Okay, after 5 seconds, that means t0 plus 5 seconds. Okay, the speed. This is suppose v0. This is v. That is 20 meter per second. See, I can do one thing over here. If I just take t0 as 0 itself, okay, that means initial velocity. If I take this v0 as initial velocity 10 meter per second, okay, I know sometime 5 seconds. The speed also I know, the final velocity 20 meter per second. I'm just considering this t at t is equal to t0, the velocity is 5 meter per second. Okay, so that I'm taking as initial speed or velocity. After 5 seconds, the final velocity is 20 meter per second. Then by doing that, I can find out what is the acceleration of the particle. As the particle is moving with constant acceleration, I can get some value from here. See, look, I know v is equal to v0 plus at, since the particle is moving with the constant acceleration. So v0 is 10 plus at. I have to find out t is 5. Okay, and this side it is 20. Look, then I can easily get a is equal to 10 by 5, that is 2 meter per second square. Okay, this is 2 meter per second square. So this is acceleration. So I have got acceleration. Now in 3 seconds, how much distance it can travel, I can find out. The velocity, velocity, how much velocity it could have, I can find out, isn't it? So what is the velocity? So velocity, see, initially it was at rest. Say in 3 seconds, how much distance it can travel? In 3 seconds, it can travel u is 0 plus, like it can travel 3 seconds. Within 3 seconds, how much velocity it can achieve, okay, or acquire? That is, or I can go with another intuition. See here, the question is you have to find the velocity when at t0 minus 3 seconds. Okay, t0 minus 3 seconds. I can do one thing. Let me find out velocity at t is equal to 3 seconds. If I just say that the particle starts with, see, moving from rest. Okay, if I say it is moving from rest, then this is 0, at, a into t. So a is 2 and t is 3. So this is meter per second. So in 3 seconds, actually it can acquire 6 meter per second. Now see, in t0 time, it has got velocity 10 meter per second. Then t minus 3 second, it can acquire in t minus this second. The velocity will be 10 minus of this, okay, or 4 second. Sorry, 4 meter per second. Okay, so it is 4 meter per second. If you are having the trouble with this, let me just do one thing. See, I have taken t is equal to some time when the velocity is 10 meter per second. I know the acceleration, that is 2 meter per second. Okay, now 3 seconds before, that means time is this. Okay, how much was the initial velocity? Let me take this as initial state. So what was the initial velocity at this time? I have to find out u is equal to what. Let us find out that. So so 10 is equal to u plus a minus t0 minus this. Okay, so for that actually we have to do one more thing. Velocity at t0, suppose starts with, this is t0. So you know this is, so t0 is actually, if I take this initial state, particle moving with constant acceleration at an instant t is equal to 0 is 10 second, sorry, 10 meter per second after 5 seconds. So obviously this what I have done is correct. That is, see, if I find out what is the velocity attained by 3 second if a particle starts with no velocity or zero velocity, so that is 6 meter per second. I can just take the difference, okay, or subtract from 10, so I get 4. This is the answer, but we can do in some other way. Let us say the velocity is 10 meter per second, acceleration is done, known, initial speed is 0, say. Okay, so in that case, so what is the time t0? So 10 by 2, 10 by 2. Okay, this I can get as second. This is second, that means you know this is 5 second. If I do that here, let me find out u. This is 2 into 5 minus 3 second. So t0 I have found out what is t0. T0 I have got as 5 second. So now we have u plus 2 into 2. Okay, this is already 10. So u will be 10. I see. This is 2. Okay. Six meter per second I'm getting. No, I think then this is all right. What I have done, this is the answer, 4 meter per second. That is for sure. Okay, so what I have done here, I have taken at t0, the velocity at t0 to be the initial speed. Okay, at that particular instant. Okay, t0. Then in 20 second, sorry, 5 second, t0 plus 5 second, that I have taken as 5 second, and if I take this as initial speed, then I can get the acceleration. Once I get the acceleration, I know in 3 seconds if the initial speed is 0, but this is not mentioned anyway. The velocity of a particle moving with constant acceleration. Speed is not mentioned initially. How much is the speed? So that's why initial speed I have taken as 0. So in 3 seconds it will move actually 6 meter per second. So 3 seconds before, okay, how much would be the speed? By 3 seconds it has moved already 6 meter per second. So t0 minus 3 seconds, in this time it must be moving with speed less than, less by 6 meter per second. That is what I am doing here, and by doing that we are getting this 4 meter per second. All right, I'll just try to make this solution in another way also in the next class, and we'll clarify it. So this is obviously, this is true answer. Answer is correct, and the method is also correct. We'll try to make the solution for this in another method and see whether we are getting the same answer or not. Okay, so let us solve now this question. The velocity acquired by a moving body, a body moving with uniform acceleration given. The velocity acquired by a body moving with uniform acceleration is 30 meter per second in 2 seconds. In 2 seconds. So acceleration is not given. Okay, moving with this, and t is given 2 seconds, and the velocity acquired by the body is given as 3 meter per second. This is what is given, and velocity acquired in 4 seconds is also given. Velocity, this is v1, say this is v2, this is 60 meter per second, and time it takes 4 seconds. Okay, so what is the initial velocity? That is what we have to find out. But before that, acceleration also is required to find out, isn't it? See, phi is equal to u plus at, that we know. So in both cases, I just put the value. Say at 2 seconds, we know this is 30 meter per second, and u I don't know. What is a? A, I have to find out what is the time. Time is 2 seconds. So 2a. Okay, this is 60 seconds. U plus 4 into a. Now if I just take the difference from this, this, let us say this is equation number 1, this is equation number 2. I have to take difference from 2 to 1. Okay, let us do this in this 2 minus 1. If I do, so what we will get? We'll get as 2a is equal to 30. So a will be 15 meter per second square. So I have got the acceleration. Now I have to find out what is initial velocity. Let us do it here with this equation. So v is 30. Initial velocity I have to calculate. Acceleration 15 meter per second. Time is given 2 seconds. Okay, 2 seconds. So u is 0 according to this. Here also, if we use this equation also, we'll get u is equal to 0. So initial speed or initial velocity of the particle is 0. Option 1 will be the correct answer for this question. Okay. Now this question says a body starts from rest with a uniform acceleration, this, for 5 seconds. During next 10 seconds, it moves with uniform velocity. The total distance traveled by the body. See, initial speed is 0 for a particle. It is moving with a uniform acceleration. Acceleration is given, that is 10 meters per second square, and moving for some 5 seconds. Okay, first it is moving for 5 seconds. The next 10 seconds it moves with uniform velocity. So what is the velocity I get when it is moving with acceleration this for 5 seconds? That is a into t. U is 0. So what is the speed or velocity I get? This is a is equal to this and 5 seconds, so 50 meters per second. This is the velocity acquired in 5 seconds. Now let me tell you, see, suppose the total distance I have to find out. So total distance is s, which is composed of s1 plus s2. So first s1, okay, up to 5 seconds, s1 up to 5 seconds, it is moving with constant acceleration. Okay, and rest of the distance s2, say, I don't know that how much it is. It is moving with velocity, constant velocity, 5 meters per second, sorry, 50 meters per second, and acceleration is 0. Okay, it is moving for 10 seconds. Okay, 10 seconds. So then can you find out what is s1? S1 is, see, u is 0, so half 80 square. Okay, so that I get, see, a is given 10, t is 5 second. Okay, that is 25 then. So this is 5, so 125 meter it goes. S1 is equal to 125 meter in 5 seconds. Another 10 seconds it moves, so that is s2. S2 is equal to v. V is the 50 here into t. T is 10 seconds. So this is again 500 meter. So what is the total distance is travel? S1 plus S2. So S will be 500 plus 125 meter as a whole. So then it is 625 meter. So option 4 will be the correct answer for this question. Okay, now let us go to the next problem. What is this problem saying? Initially, a body is at rest. If it accelerates, its acceleration is 5 meters per second. So initially it was at rest. Acceleration is given 5 meters per second square. So it traveled, then the distance traveled in 18th second. 18th second means, suppose you have up to 17 seconds, 1 2 3 4, like that, up to 17 second. Then this is 18th second, just 8 that second. So this is 19 second. Okay, up to here it is 17. Okay, and this is 19 seconds. So during this particular time, okay, this particular time, that means, okay, so we have to find out what is the distance traveled. We know the formula. Sn we know. Distance traveled in n second will be u plus a by 2 to n minus 1. So this is the one formula. Let us put these values. See, s 18th. Okay, so n is here 18th, u is 0, acceleration is given 5 by 2, then here 2 into 18 minus 1, that means what, 5 by 2, this is 35. I don't know, there will be fraction, so this is 2.5, so 2.5, so 35 into 2.5, so 25 5 ja 125, 12, 20. So this is, I think, 87. Okay, 87 and this 87.5. So option 2 will be the correct answer for this question. Okay, so it is 87.5 meter. So this is very important formula. Ascent. Okay, in 10th second, 15th second, 5th second. So this kind of question may come in exam. Okay, now let us see what is this question saying. This question says if a train traveling at 72 km per hour is brought to rest at a distance 200 meter, then its retardation is how much? Then its retardation is how much? See, the speed, the particle, okay, initial speed is given as 72 km per hour. Okay, kilometer per hour, we know kilometer per hour can be converted into meter per second by multiplying 5 by 18. So this is 4. So this is 20 meter per second. Okay, 20 meter per second speed. Now it is actually stopped in 200 meter. So what will be the acceleration, sorry, deceleration or retardation? We know this formula, right? V square is equal to u square minus 2as if this is decelerated motion. If I want to stop it, then the final velocity is going to be 0. Then we have to find out what is the retardation. So retardation A will be u square by 2s. So what is u? Use this by 2 into s. S is how much? 200. I see. So this will be actually 1 meter per second square. Retardation will be 1 meter per second square. So option 4 will be the correct answer for this question. Okay. Now let us go to the next problem. Okay. So what is this problem saying? This problem is saying that a car moving with speed, sorry, a velocity 10 meter per second can be stopped by application of force F in a distance this much meter. Okay, that means this is okay. If the velocity of the car is 30 meter per second, it can be stopped by the force in how much distance? So we know in this case also, see, initially it is given, initial information is this, one information is given like this. So suppose u is something 10 meter per second. Okay, so distance is 20 meter per second, within which it can be stopped by the application of force F. So I can actually find out acceleration from here. So A will be F by m. M is the mass of the particle if I require. So in this case, look, the second part is if the particle, if some particle has, okay, if the particle has initial velocity 30 meter per second, then with the same force, within how much distance we can stop this particle, okay, or the moving car or whatever. Okay, this is moving car. So with the initial velocity 30 meter per second, within how much distance we can stop it if I apply the same force. Look, in this case we don't know the value of this force and all. Let me find out here. Actually we have to find out what is the acceleration. So acceleration will be u square by 2s, as you know, 2s. So u is, this is 100 divided by 2 into this. Okay, so this will be actually 5 by 2 meter per second square. So we got the acceleration, which is actually F by m. I can write that F by m also. So if I know the acceleration, then we know the force also. Okay, that is fine. So yeah, so same body, same car. That means this is like, this is the same. So therefore acceleration and force I can take as same. So in this case, see, initial speed, final speed has to be 0. So here I have to find out s. Okay, I have to find out s. I know the acceleration. As I have to find out, so u square by 2a. 2a. So what is u? U is here 30 meter per second square, sorry, meter per second. So that square into 2 into a is here 5 by 2. So this two can cancel each other. So this will be 900 by 5. That means 180 meters. Okay. So option 4 will be the correct answer for this question. All right. So let us go to the next problem. I'm sorry. So with this, I'll stop it here. We don't have more questions today. So I think this free fall part, we could not take up questions. So in the next class, I'll take up a few more questions on constant acceleration part and many more questions from free fall in the next session. Okay. So thank you for your patience. Bye for today.